Okay, so we have the following points that we're going to be looking at. Okay, we've got the camper here, camper prime. Then we've got 12. We've got the tent. We have tent prime. And now we're going to create these lines to show those distances. Those are reflections. Therefore, we know these two segments are congruent. We know these two segments are also congruent. Now we can go into the idea that we're going to create a line between C and T prime, the shortest distance between those two points. And then we're also going to create the shortest distance between C prime and T. All right, and now by doing that, let me highlight the river here. We should be able to see some triangle congruencies. So in this case, we've got this triangle is congruent to this triangle. And because that's true, we can then draw in congruencies on our triangle. So we know the angle here is congruent to the angle here. We know that angle up there is congruent to the angle by T prime. Then we also know that these two angles are 90-degree angles, therefore congruent to each other as well. Now, in this case, we also now can use, so this is the triangle congruency theorem, I believe. Triangle congruency. I don't know the terms after. I mean, I'd have to, this is stuff that I'd have to, when I'm teaching this, I look at. Triangle congruency says that the angles here are congruent. The corresponding, let me say it that way, corresponding angle congruency is what you could use here. And that's what tells us that these triangles are congruent, or you know they're congruent, therefore it tells you the other. All right, so in that case, now let's go ahead to vertical angles. Since we know the angles here are vertical, we now can say that they are congruent. So now we've got those statements done, vertical angle congruence. All right, now we can state another theorem, or I think it's a theorem, more theorems, states that in this case, because we know that these two corresponding angles are congruent on both triangles, then the third must also be congruent to each other. So we can state that angle C prime and C are congruent to each other. That's the triangle sum theory, something along the lines of that. And now if we go to stating, okay, we know that C prime and C are congruent to each other, but what about how that relates in both triangles? Well, because we know that these two angles are congruent to these two angles, we can then say that the third are equal to each other as well. Meaning it's okay to put this one arc on here and this has a one arc because we're able to say they are congruent. And now for, it looks like, I think the last piece, which is, similarity. Now, because of these statements, the angle corresponding angle congruency, but the side lengths are not equal, meaning that they are similar triangles. Equal similar triangles. Once we know we have similar triangles, then we can say that they are proportional. So the triangles on the left are proportional to the triangles on the right, which is why we can say if this is 300, then this would have to be 600. And then the intersection being at 8 makes sense, 800, because this would be a segment length of 800, while over here you'd be at 400. So once again, similarity, the left triangle is 2 times the distance the right of the segment lengths as the right triangle. I'm sure there's lots of room for improvement in that explanation, but that's what I got for right now. So let's see.